If you've heard of Redis, you probably think of it as a cache. That's only one of its jobs. Think of Redis as a super fast file cabinet that lives entirely in RAM. You give it a key, like a label on a drawer, and it stores a value there. The value isn't always plain text. It can be a counter, a list, a set of unique IDs, a ranked leaderboard, or a stream of events. That flexibility is what makes Redis so useful in real backend systems. Traditional databases write to disk on most operations. Disk is reliable, but slow compared to memory. Redis keeps its working data in RAM, so a command can find a value almost instantly. There are no SQL joins and no full table scans for a simple key lookup. You send a key, Redis returns the value. The trade-off is capacity. Redis can only hold what fits in memory, so you choose carefully what belongs there. Every piece of data in Redis lives under a unique key. A key is just a string label, like user 1042 session or product 1011 cache. The value behind that key can be a simple string, or a richer structure like a hash or a list. Your application never scans tables looking for rows. It asks Redis for a specific key and gets an immediate answer. That simple contract is the foundation of every Redis pattern you will learn in this course. Calling Redis only a cache undersells it. Yes, Teams cache database query results in Redis every day. But Redis also stores login sessions that expire automatically. It runs atomic counters for page views and rate limits. It holds job queues for background workers. It ranks players on leaderboards. And with streams, it can append durable event logs. Same server, many jobs, each using the data structure that fits the problem. Here's how those jobs look in production. Sessions store a login token under a key with a time to live so old sessions disappear without a cleanup cron. Caching stores a serialized database result under a product or user key so the next request skips the database. Counters use a single atomic increment so two servers never race when updating a view count. Queues push email or webhook jobs onto a list and workers pop them when ready. Leaderboards keep players sorted by score so top 10 queries stay cheap. Redis is a data structure server. The 6 types you will use constantly are string, hash, set, sorted set, list, and stream. This masterclass also gives full lessons to Bitmap, HyperLogLog, and Geo. We demo the 6 next, then preview the specialty 3. Each gets its own deep dive later. Start with strings. Use set to store a feature flag under dark mode, then get that key back. Redis returns on. Same pattern for a session token or a cached JSON blob. 1 key, 1 value. The same string type powers counters. Call increment on page views to bump the count safely, then get the key to see the new number. 2 servers can increment at once and Redis still keeps the correct total. Hashes model flat objects. With hset, store name, email, and plan under user 42 in one go. Then get just the email field. You update one piece without rewriting the whole profile. Sets store unique members. Use sadd to put Redis in cache on a product tag set. Add Redis again and it still appears only once. Members shows the unique list. Same idea for online user IDs. Sorted sets add a score to each member. Use zadd to put Alice, Bob, and Kara on a game leaderboard with their points. Then zrevrange with scores returns the top 3 high to low. Redis keeps the ranking ordered for you. Lists keep ordered sequences. Push a welcome email job onto the mail queue. When a worker is ready, rpop takes that job off the list. Producer pushes, worker pops. A simple queue with 2 commands. Streams append events in order. Use xadd to write an order paid event onto an order stream. Redis gives it an ID. Use xrange to read that log back so consumers can follow new events or replay history. That durability is why streams fit pipelines and audit trails. 3 more types get full lessons in this masterclass. Bitmaps flip individual bits, dense flags, and presence calendars. HyperLogLog estimates unique counts with a tiny footprint. Geo stores longitude and latitude for nearby queries. After sorted sets, we deep dive each one with real commands, then move into messaging and coordination. Keep this architecture picture in mind. Your application does the work. Your primary database is the warehouse, permanent, queryable, and slower for hot paths. Redis sits in between like a desk next to you. The items you reach for constantly live there for speed. When something is no longer needed, time to live can expire it automatically. Redis does not replace your database. It accelerates the paths that must stay fast while the database remains the source of truth for durable records. Before patterns and data structures, confirm you can talk to Redis. Start a local server, then open the Redis command line. Type ping. If Redis answers Pong, your connection works. That tiny handshake matters. Every later example assumes your client can reach a running Redis instance, whether that is Docker on your laptop or a managed Redis in the cloud. Here are the first commands every engineer learns. Set a greeting to Hello Redis. Get greeting returns Hello Redis. Exist confirms the key is there. Del removes it. Type tells you the value is a string. These commands look simple, but they are the same primitives behind sessions, feature flags, and cached JSON blobs. Temporary data is where Redis shines. Set a session key for user 42 with an expiry of 30 minutes. Check the remaining time to live to see the seconds left. When the timer hits 0, get returns nil because the key is gone. No cron job required. Lesson 2 goes much deeper on key naming, sliding sessions, and cache aside with time to live. Redis executes commands on a single main thread. That sounds like a limitation, but for many workloads, it is a feature. 2 clients can increment page views at the same moment, and Redis still applies those updates one after another with no lost counts. You do not need application locks for a simple counter. The cost is that a slow command blocks others, which is why production Redis avoids heavy key scans and prefers scan instead. Remember the primary model. Redis serves from memory. For durability, Redis can also write to disk. RDB snapshots dump the dataset periodically. AOF logs every write so Redis can rebuild state after a restart. Managed Redis providers usually enable persistence for you. For this course, treat persistence as a safety net, not the reason Redis is fast. Speed still comes from RAM lookups. Use Redis when the access pattern is simple and speed matters. Sessions with automatic expiry. Cache aside for hot database reads. Atomic counters and rate limits. Lightweight queues and activity feeds. Rankings with sorted sets. Avoid Redis as your only store when you need multi-field joins, heavy ad hoc analytics, or datasets larger than available memory. In those cases, keep PostgreSQL or another database as the system of record and let Redis accelerate the hot path. Drop a few myths early. Myth 1, Redis is only a cache. Reality, it is a data structure server with many jobs. Myth 2, Redis replaces your database. Reality, it sits beside it. Myth 3, everything in Redis lives forever. Reality, time to live and eviction policies exist because memory is finite. Myth 4, any command is safe in production. Reality, a full keys scan or unbounded US members can block the server. Knowing these boundaries keeps your designs honest. Here is the roadmap. Next, we master keys, naming, and time to live. Then strings, hashes, lists, sets, and sorted sets. Then full lessons on bitmaps and bitfields, HyperLogLog, and geo. After that, pub-sub versus streams, consumer groups, and finally rate limits and distributed locks. By the end, you should be able to pick the right Redis tool for a backend problem and prove it with real commands. Here is what to remember. Redis is an in-memory data structure server. You address data by key. Caching is one job among many. Sessions, counters, queues, leaderboards, and event logs all fit. 9 structures get full lessons in this masterclass. Redis sits between your app and your database as the fast desk, not the warehouse. Next lesson, keys, time to live, and expiry. The foundation of temporary data.